Good day everyone, welcome back to our chemistry series. Today we will be discussing particulate nature of matter. History of the atom. The word atom originates from a Greek word which means something that cannot be split. However, it was later proved that atoms were split. In 1897, J.J. Thomson put forward his plum pudding theory. According to him, atoms were balls of negative charge with tiny positive particles inside. The negative particles were called electrons. He said they were like Christmas pudding. This model explained Thomson's experiment with electricity, that is, cathode rays experiments. However, later experiments using radioactive particles needed to be reviewed. Lord Rutherford and Bohr's model in 1915 were more plausible and could explain diverse natural and artificial phenomena. This model is still useful today. Now I'm going to be talking about some timeline for notable events involving the atom. Now the first, in 1805, according to John Dalton, atoms of the same element are alike, they react to form compounds. In 1897, J.J. Thomson discovered the electron, a negatively charged particle that surrounds the nucleus. In 1886, Eugene Goldstein discovered the proton, a positively charged particle. According to Rutherford, it coupled with the neutron to form the nucleus. Ernest Rutherford discovered the nucleus of the atom as the center of the atom, which is incredibly small and dense, while James Chadwick discovered the existence of neutron, a particle of equal mass as proton but carries no charge. Concept of atom, molecules and ions. Now let us begin to refresh our memory on matter. Matter is any substance that has mass and occupies space. It is made up of discrete particles such as atom, molecules and ions. What are atom? An atom is the smallest particle of an element which can take part in a chemical reaction. Atoms of different elements have various shapes. Now molecule. A molecule is the smallest particle of a substance that can exist alone and still retain the chemical properties of that substance, be it an element or a compound. The number of atoms in each molecule of an element is called the atomicity of the element. For example, oxygen and chlorine are diatomic, that is, having two atoms. Others like phosphorus and sulfur are polyatomic molecules. The molecule of iron are monoatomic, that is, they can exist independently as single atoms. Also, consider situation where the number of atoms in the molecules of a compound may be small or large, e.g. hydrogen chloride with two atoms while a starch molecule with thousands of atoms. We have a table showing the atomicity of some elements. We have for neon the atomicity is 1, argon is 1, hydrogen is 2, nitrogen is 2, oxygen is 2, ozone, that's a form of hydrogen, is 3, phosphorus is 4 and sulfur is 8. Ions are atoms or group of atoms which possesses an electric charge because they have gained or lost an electron. There are two types of ions. One, the positive charge ions called the cations, e.g. K+, Na+, Ca2+, Fe2+, and NH4+. Two, the negative charge ions called anions, e.g. OH-, Cl-, NO3-, and SO42-. Ions are produced when atoms lose or gain electrons. For example, sodium loses an electron to become NH+, magnesium loses 2 electrons to become Mg2+, chlorine gains an electron to become Cl-, and sulfur gains 2 electrons to become S2-. Now we have some examples we'll be going through. The first is from 1994 and it states that polyatomicity is illustrated by the molecules of A. Sulfur being carbon dioxide, C. Noble gas, and D. Liquefied oxygen. Now sulfur exists in polyatomic state. We have S4, S8. So polyatomicity is illustrated by the molecules of sulfur, and the correct option is A. The second question is from 2020 and it states that a molecule could be a group of A. Atoms bonded by ionic bonds, B. Atoms bonded by covalent bonds, C. Ions bonded by covalent bonds, and D. Ion bonded by ionic bond. Now the correct option is B. Atoms bonded by covalent bonds. Our next question is from 2010 and it states that which of the following elements is diatomic? A. Iron, B. Neon, C. Oxygen, and D. Sodium. The only element here that is diatomic is oxygen, which exists in the form O2, and the correct option is C. The next question states that an ion is A. Positive charge, B. Negatively charged, C. Positively or negatively charged, and D. Neutral. Now an ion is an element that has charge either by loss of electron or by gain of electron, so it is either positive or negatively charged, so the correct option is C. Now our next example states that atoms are electrically neutral because they A. Do not conduct electricity, B. Contain equal number of proton and neutron, C. Are composed of neutrons and electrons, D. Cannot be attracted by electromagnetic field. Now atoms are electrically neutral because they contain equal amount of proton and equal amount of electron, so they have equal amount of positive and negative charge which cancel out and they remain electrically neutral, so the correct option is B. Our next example is for 2007 and it states that when sodium atoms form the ion Na plus, A. It gains one electron, B. It gains one proton, C. It achieves a noble gas configuration, D. Its atomic number increase. Now for our solution, all elements ionizes to obtain the noble gas configuration. In the case of sodium, it has one electron in the atmosphere which it loses and is left by 8 in the atmosphere, which achieves a noble gas configuration, and the correct option is C. For our last question, it states that calcium atom ionizes by calcium ion ionizes by the loss of its two atomos electron, so the correct option is B, that's losing of two electrons. Here are some exercises for you to try your hands on at home. And for more insight on this topic, you can check out the chapter 3 of our hidden facts chemistry textbook. You can get the hard copy in bookshops, or if you are interested in the soft copy, you can get it at the website on the bottom of the screen. Thank you.